Now, moving outside of all of those exponential rules, we're going to go into solving specifically the most often used radical, which is the square root. And so if we're solving with a problem with the square root, we want to, for starters, get the square root by itself. That's already happening in this equation. So my next step is to undo that square root. To undo a square root, you square both sides. So I'm going to square both sides. I get rid of my square root on the left side. 2 squared becomes 4. And then I just go ahead and solve through. This is a two-step equation, kind of a simple equation to solve. I add 2 to both sides. I divide both sides by 3. I get x is equal to 2. Now, if we're dealing with square roots, this is the first time in the class where it no longer becomes oh, this is a good idea to check your answers, and now it becomes very much you have to check your answers, because you can do everything right, everything can be perfectly fine, and then your answer could still not work. Maybe it's the second time we've talked about that. Anyway, so we need to take our x equals 2 and plug it back into the original equation. We do that by plugging into 3 times 2 is equal to 6, minus 2 gets me 4, square root of 4 is 2. So I see that both sides of the equation are equal to each other. So notice how in the checking thing, I'm not going to be moving things on other sides of the equation. I'm just simplifying each side to see if those are equal to each other. In this case, they are. If I get an answer that doesn't work, I don't include it in my solution. If all of my answers don't work, we say that there is no solution, and the answers that didn't work were extraneous is the fancy word. If you want to write it, I'm perfectly fine with you just taking an equal sign and putting a slash through it. To move on to a little bit more difficult of a problem, same starting point. I want to get the square root by itself. Well, fortunate again, that's already happening. So I'm going to square both sides, get rid of the square root. Now we have to be careful on the right side. That does not become x squared minus 4 squared. We have to write out the term twice and FOIL it out. So the left side's, the square root's going to cancel. The right side, if I FOIL out x minus 4 times x minus 4, it becomes x squared minus 8x plus 16. That one I kind of skipped a few steps as far as foiling goes, but that's all I was doing. That's kind of all that's missing in between those steps. If you don't feel comfortable with that jump, FOIL x minus 4 times x minus 4, and ideally you will get what I have on that right side, x squared minus 8x plus 16. Well, now this is a question very similar to the first section. I have a squared, I have an x, I have a regular term. I'm going to move everything on one side and get a 0 on the other side. So I started by subtracting 16 from both sides, 16s go away. Next I subtracted x from both sides, so I got x squared minus 9x. Now I'm going to factor out an x out of both of those terms, kind of something similar to what we saw 2 slides ago. This one's a little bit simpler because we don't have a rational root, but same concept. I'm going to divide x from both terms and put it in front, so I get my x in front of my 2 terms, and x squared divided by x is x. 9x divided by x is 9. I'm going to set both terms equal to 0 and solve. Well, the first one's a freebie, x is equal to 0. Second one is x minus 9 is equal to 0. I'm going to add 9 to both sides, so I get x is equal to 9. Now, I need to go back and check both of these solutions. So for starters, I'm going to check x is equal to 9. Well, I plug it back into the very first step of my problem. I don't do it any time later when I've done solving because maybe I made an error. So I go back to that very first equation that has a square root. I plug in 9 to both sides. Right side becomes 5. Left side becomes square root of 25, 16 plus 9. I square root the 25. I'll get 5 is equal to 5. Great, my answer worked. I can go ahead and box my x is equal to 9. I kind of jumped the gun. But I can go ahead and box that. That solution will work. Now I have to check my other solution. So I plug in 0 into my original equation. Well, that becomes the square root of 16 plus 0 minus 4. Well, square root of 16 is 4. 0 minus 4 is equal to negative 4. So my answer didn't work. So I would cross out my equal sign and say x does not equal to 0. Or if you're feeling particularly fancy in the moment, you can write x equals 0 as an extraneous solution. Whatever you need to do to tell yourself or to tell me that that does not work. Even though we did all the steps right, there wasn't any errors along the way. It just simply that did not work when we were dealing with square roots. A cube root. Very similar process. I want to get the cube root by itself, but now to undo the cube root, well, I have to cube both sides. Then I'll be left with x minus 2 is equal to negative 8. Add 2 both sides. Add 2 to both sides, I will get x is equal to negative 6. And now I'm going to check my answer just like we've been doing with the square roots. I plug my negative 6 into the x of the original equation, so I get that negative 6 minus 2 cube root plus 1 hopefully is equal to negative 1. Negative 6 minus 2 gets me negative 8. Cube root of negative 8 is negative 2. Negative 2 plus 1 is negative 1. And my answer works, so I can go ahead and box my solution. Now, a little bit of a secret about cube roots. If you are doing your problem-solving process correctly, you don't really need to check it. You're never going to have a cube root problem where you go ahead and solve it, everything works, and then you get your answer, you check it, and it doesn't work. So that is very, very, very true of square roots. You always, always, always need to check your answer, where with cube roots, you don't really need to check an answer. Always, it's a good idea to check a math question, check your answers for a math question, not necessary for a cube root. So this next problem, I guess we have a lingering error. I'll probably see you in a while. This is, I've taught this class a few times. I have never seen anything like this on a test because it's a very difficult problem and it has a lot of steps to go through, so it would just take too much time on a test. Obviously, I can't predict the future, and I don't write your tests. My course captain writes them. So there is a very, 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 very small shot it will show up. And if it does show up, I'll tell everyone and say, go back to that crazy challenge problem I did. And I think there is one problem on the homework. But all of that aside, I don't think you'll see this one again. And so I'm going to go through it. I'm going to go through it fairly quickly because it is going to take up the entirety of the slide all the way down for the single problem. But I'm not going to break down every single step as that I have done on every other example, and I will likely do that on the future. So if you like challenging questions and you like very difficult problems, this is the problem for you. Follow along. If you kind of want to just track on what we've been doing in this section and maybe you're already struggling with, maybe just even skip through this slide so that you don't get overwhelmed, because it is a very overwhelming problem. Okay, disclaimer out of the way. Let's get to it. Now I have 2 square roots, so I can't really just isolate the square root because there is not a single square root. So instead, just pick one. So I think I picked, I isolated my square root of 3x plus 7, so I moved my square root to the other side. Next step, same as the previous ones, I square both sides. But now I have to FOIL a square root, which is kind of difficult to do as far as the concept goes, but it's the same exact concept. If you're doing FOILing, you multiply the first term by the first term, and the first term by the second term and the second. Anyways, when you FOIL it out, this is what it becomes. So that gets rid of this square. If I square that square root on the very right side of that expression, I get x plus 2. And now that I've gotten that scary FOILing with the radical out of the way, well, I can just move everything to one side again, and then I restart my problem as though it was not a terrifying problem. So that's all those 5 steps we're doing, is moving after I squared that x plus 2 on the right side of that 1, 2, 3, 5th line. Every other step outside of that was just moving everything to the other side. So I added 3 and then I moved the x over, then I moved the 3 over, then I divide by negative 2, and so I'm left with this. Well, again, I'm going to square both sides. So if I FOIL out my left side, I'll have x squared plus 4x plus 4 is equal to x plus 2. I subtract the x plus 2 over, I factor, I get x is equal to negative 2 and x is equal to negative 1, and I'm not going to write the checking because I just don't have space on the slide. But x equals negative 2 does work. That solution is correct. X equals negative 1 is not a solution. It's an extraneous solution. So I put a slash through the equal sign, and I'm done with it. And that's it for this lecture.